Hi, this is Steve Seyfried from Seyfried Cymbals. One of the things that I love about cymbal making and music in general is being able to apply one of my other loves to it, which is physics. And just the behavior of how the instruments work and the acoustical physics aspects of the instruments. And I was playing this cymbal earlier today, and with the light just right, how it was through the window and the shades and everything, I got to catch a glimpse of some of the vibrational modes of how the cymbal was actually vibrating. And it was very cool, so I took some film of that, and I'll show you that here in just a minute. Basically, I could see how the cymbal was flexing in one of the ways that it was flexing. It will flex in a whole bunch of different ways. I've got this very bendable cymbal here. I'll show you kind of what's going on. In a no jargon kind of sense, just thinking about it kind of mechanically, like what would happen. Here's what happens when you hit a cymbal. This is one of the things that happens. It's incredibly complex, but this is one. So let's say you hit with a stick right here. Boom, that's a stick. This whole thing flexes down, right? Even if it's a much firmer metal, it still flexes. You just can't see it. So it flexes down. But as it's flexing down, then this part pulls down, so then the part next to it's going to pull down some too, because they're connected. And then because this has pulled down, the part next to it is going to pull down, and then because that, and so on, all the way around the cymbal. Now, once part of it has gone down, the metal is bendy and has what they call a restorative force. It wants to flex back up, so it kind of spring loads itself back up. Now it becomes up, and then it pulls the part next to it up, and then that pulls the part next to it up, and that pulls the part next to it, etc. But when it pulls up, it actually overcorrects. Now it needs to spring back because it's up too high, so it's going to pull down again. But then it overcorrects again and goes down too far, and then it pulls the part next to it down, and so on, and then it corrects back, and then it goes back, and so then you get one part here that's flapping up and down, and then the parts on either side are going along for the ride. Like they get the flex next. Then it flexes and it goes all the way around. This is one of the ways that a cymbal can vibrate. I'm not going to get into the other ones, but it can go all the way around, and I think you're going to see that in this video. And then you get into a place where, well, if this whole thing is kind of in a down, cool, and then it has gone around, now this is down, and this is up, and then as that moves around, maybe this one's down, now the up is here, but this was just down, so it is now up again. Stay with me. Goes around again, this is the down, but this now has sprung back up, this is the down from here, moved over here, this one has sprung back up, right? So now you have down, up, then it rotates around again, now you have down, up, down, up, down, up, and so on, and you get this kind of flapping thing. You get this down, and then the other two are up, and then that kind of moves its way around. So these are down and these are up, all right? And then that just keeps going all the way around. And this is one of the vibrational modes. It'll also be doing this way more times. Like you could have 16 downs and 16 ups all at the same time. 10 downs, 10 ups, I think. Anyway, and then those are going to be higher and higher and higher frequencies. But if you're doing something like this would be an incredibly low frequency. But I think you're going to see that you can actually see that when I'm playing this video, or when I'm playing this cymbal in the video. And then one of the things that as this transient really is going around the cymbal, remember that the flex and bend thing is going around, and then around again, keep in mind it's going in two directions. And then they meet in the back, and then they're opposite, and then they meet. And they're opposite, and then they meet, and then they're opposite, and then they meet. So you end up getting this combination. It's combining here and opposing, and you end up seeing spots where there's a part of the metal that is just flexing up and down and up and down, and then other parts where it's not budging at all, because that's where the two waves that are coming around cancel each other out. One is saying, I want to go down, the other one's saying, I want to go up. Right in that spot, they cancel each other out, so it doesn't go anywhere. It just sits there, but then as they pass each other again, now you've got a down here and an up here or whatever's going on, and now it's flexing again. But then there will be a spot where they line up again, and they exactly contradict each other, and now it's not going to budge again. And then, okay, well, they don't line up nearly as well here, so it's going to start flexing a little bit. Here they are in agreement, and they're both saying flex, 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 and then they start disagreeing again, and then, so you get this pattern of flexing and just holding still. Technically holding still, you'll see in the video there's a little bit of movement, but generally speaking, it's holding still. The place where it doesn't move at all is called a node, and the place where it is moving the most is called an antinode. A node is a place where you could say there is no excursion, and the antinode is where there is maximum excursion. There's the most amount of distance being moved. So you'll see how those set up when you hit the cymbal. Well, without further ado, here we go. All right, so I'm playing this back at 10% speed so you can really see how these relatively fast vibrations happen. You get a chance to get them, be able to see it a little bit better. All right, so just a couple times around, the transient went around the cymbal just a couple times. It's incredibly fast, but now we've set up these resonance zones, if you will. So we've got antinodes, we've got 4 antinodes and 4 nodes, and you can see that the node areas really aren't flexing. The antinodes are moving a bunch. So here I am pointing out, because I could see this in person in real time, and you're going to hear me say it really slowly. So we've got opposing areas, so let's say the top right and the bottom left are always going down at the same time or up at the same time, and then the bottom right and the top left are always going down or up at the same time, and they oppose the area next to them. So you can see it kind of rocking back and forth at the node. At each of the nodes, where the regions to the left or right are kind of alternating on either side. That's another node, except I was off just a little bit. All right, so hopefully you saw how it was going in those 2 downs, 2 ups sort of configuration, and being able to see a little bit of the chasing around the cymbal as it flexes and runs around in a circle. But what was interesting about this cymbal is there is a peak. There's just a bend right about here. Yeah, there's kind of 2 of them, but they're in this area. And what that's making is, because there's kind of this kind of fold that's going on right there, it's really strong and it doesn't want to flex like a nice flat section would. It's like, I don't want to bend. So it actually changes the vibrational modes of the cymbal if I hit it in a different spot. If I hit it in a spot that is supposed to make this spot right here flex the most, then it can't, and it actually breaks it up and moves it around and rotates how the cymbal is flexing to make it so that this is the spot that doesn't flex and the parts around it do. So check that out. In order to get the nodes and antinodes to align like I have here, like I've put in this mock-up, I'm going to need to hit on one of the antinodes, and ideally right in the center of it, because that's going to excite that part to flex as much as possible, which then will just feed into that particular pattern. I could really hit it anywhere around the cymbal, and it would try to set up those nodes and antinodes based on where I hit it. Basically, anywhere I hit it is going to be an antinode. That's just kind of how it works because I'm flexing it with the stick. But you'll see that even though I hit it right at the bottom, right at that antinode, it actually, the whole thing kind of rotates. All right, so I missed the spot slightly, but that's all right. It's pretty much close enough. So you see I've got antinodes in the bottom and the top. Directly bottom, top. That'll change here in a bit. So you can actually see a little bit more, especially right now, you can see things kind of going around in a circle versus going up and down in a uniform place. And this is a bit of a confusing time for this cymbal, but it's going to set up here in just a second. So now, instead of having an antinode at the top and the bottom, there are nodes at the top and the bottom. And the antinodes are on the side, so the whole thing has rotated. Here's just another hit for good measure if you want to check things out. All right, so that was just one way that a cymbal vibrates. It just so happened that this particular cymbal in that lighting and all of that was showing that one method of vibration mode, as it's called, that one vibrational mode really profoundly so that I could actually get it on camera and be able to analyze it like I did. Really what's happening within a cymbal is that it's probably vibrating in hundreds, if not 1,000 different vibrational patterns like that. This was 2 ups, 2 downs, sort of that sort of thing, but you've got every multiple of that, and then there's another way that the entire cymbal will move, and then all the multiples of that. Then once you get into the shape breaks things up even more, and it gets so incredibly complex and massively complex. And if you are watching this video and you're like, I know how all that complexity works scientifically, mathematically, please hit me up because I would love to talk to you more. And all these different ways that a cymbal can vibrate in these different patterns, there's some really cool videos out there where people have done really neat demonstrations of like vibrating a metal plate, and then they put like white sand or something on it, and then you'll see the sand snap to all these really cool different shapes. That's because that's how the metal is vibrating. It's vibrating in those shapes. You've got the nodes and antinodes. The sand moves away from the antinode and moves toward the node because that's not moving. It can just hang out there. And it's the exact same thing that's going on in here. It's just in those demonstrations you can see it better. But the exact same thing is happening when you hit a cymbal, just in such an amazingly complex way. Now, I know if you're watching this, you might say, oh, well, what about this and this? And I saw this one little wiggle and it went through, and yeah, because like I said, there's so much going on, but just this was able to be shown. Also, that frequency, the frequency of the vibration that we were looking at is probably 1 hertz, 2 hertz, 4 hertz maybe. So that's how many times it goes up and down, a complete up and down and back to the center for that part of the metal, which vibrates the air, which then gets to our ears, which we hear. But 1 to 4 hertz, we can't hear that. That humans can't hear that. So I don't mean that this whole video is, all right, yep, this whole video is just a waste of time, delete it. All the same stuff is happening in the audible range. It's just we can only see that slow of a vibration. We can't see the faster ones. But all the same things are happening. The same rules apply. It's just we can't hear that particular one. But so this is one that I've been working on. It's not completely done yet. Like I pointed out, that spot at the top. But I will be finishing up. It will be for sale. So much of everything else that's around me is also for sale. So Steve Seifried, that's me. So if you go to seifriedcymbals.com, you can see, you can get more information, see things that I have for sale, check out my YouTube, at Cyfried Cymbals, and Facebook at Cyfried Cymbals as well. All right, hope you've enjoyed this kind of geeky foray into physics of cymbals.